Hello everybody, in last two videos I have discussed different type of Fourier sums definitions, and now we will be discussing here series for different ranges. So let's get started. Now we will discuss our question number third. Question number 1 and question number 2 is already discussed in the last videos. Question number 3, expand the Fourier series in the function sin x when x belongs 0 to pi. You know that x belongs 0 to pi. This is half range, because 0, pi by 2, pi, 3 pi by 2, 2 pi. When we go from 0 to 2 pi, that will be full series, full range series, and 0 to pi, that is a half range series. So there is a little bit difference of formula here. A naught outside of integration, that will be 2 upon pi. In last videos, when there is a full range series, we put a naught is equal to 1 upon pi 0 to 2 pi fx dx, but in this we will put our range 0 to pi, that is given. Whatever range is given, you will put that into integration 0 to pi fx dx, but the outside here will be 2 upon pi. It should be kept in your mind. This is only change that you should remember. Fx is equal to x sin x belongs 0 to pi. First step is put fx is equal to the formula. Then we will solve a naught 0 to pi fx dx, 2 upon pi 0 to pi sin x dx, and 2 upon pi minus cos x 0 to pi. We put pi 0 values here. You know that cos pi is minus 1, sin 0 is 0, cos sin pi is 0, cos 0 is 1. We put all these values, we get a naught 4 upon pi, same as it is in an. Outside 2 upon pi and integration 0 to pi fx cos nx dx, 0 to pi sin x cos nx dx, 2 upon pi. Now we will solve an value, multiply and divide. What we did here, multiply and divide by 2, and then we get 2 sin x cos nx, and formula of 2 sin a cos b, that is sin a plus b minus sin a minus b. We put that formula here. Then we did integration sin n plus 1x, that will be minus cos n plus 1x, and derivative of n plus 1x, that will be divided by denominator n plus 1. As it is, we did integration of this. Then we put values of pi and 0 here. You know that cos n plus 1 pi, that is equal to minus 1 n plus 1. And cos n minus 1 pi, that is equal to minus 1 n minus 1. We put those values here, and then we calculate all these values and get 1 plus minus 1 power n upon n square minus 1 out of bracket minus 2 upon pi. 1 upon n plus 1 and 1 upon n minus 1 are cancelled here. So the value of an is minus 2 upon pi 1 plus minus 1 power n upon n square minus 1. Now we will calculate Pn, that is 2 upon pi 0 to pi fx sin nx. Here same as it is, we multiply and divide here by 2. Then we solve 2 sin a sin b formula here, and then did integration, put pi and 0 in that integration. And when we solve all this integration, you know that sin n plus 1 pi, that will be 0. Sin n minus 1 pi, that will be also 0. Sin n1 minus 1 pi, that will be also 0. because sine n pi is 0, then sine n plus 1 pi, that will be also 0. Sine n minus 1 pi, that will be also 0. Sine 0 n minus 1, that will be sine 0, because 0 is multiplying with n minus 1, that will be also 0. So this whole bn value will be 0. Bn is 0 here. Now what is the last step? Last step, put values of a naught, an, bn in equation 1. What was equation 1? Fx is equal to 1 by 2 a naught summation and 1 to infinity an cos nx plus bn sin nx. And we put all these values here. A naught value, an value, bn you know already that will be 0. And then we took minus 2 upon pi outside of the summation function because it doesn't have n. And then we solve this summation, put values of n 1 2 3, and then we get this series. This is the whole answer. Question number 4 is express fx is equal to mod x minus pi x to pi, that is range lies between minus pi to pi. Whenever range lies between minus pi to pi, there is extra benefit that we can check even and odd function. First, even you know that mod x is even function. When we put x value minus x in mod, that will be x. So f minus x is equal to fx. So the function is even. If the function is even, then only bn will be 0, and if function is odd, then a naught will be 0, an will be 0. You have to find only bn. And if the function is even, you have to find a naught and an. So there is extra benefit that we know that we don't have to calculate bn. We just have to calculate an and an. By Euler's formula, we have fx is equal to first step, that is put fx is equal to formula. Then we will solve a naught by Euler's formula, that is 1 upon pi minus pi to pi mod x dx. Minus pi to pi. One thing you have to remember, when there is minus pi to pi and even function, you can change it by 2 0 to pi even function to make calculation easy. So we did here 1 upon pi 2 0 to pi mod x dx, and mod x dx, you know that 0 to pi mod x dx, that is always positive. That is always positive. So 0 to pi mod x dx, that will be 2 pi cos 2 pi x dx, and we put pi and 0 values here. Answer will be pi. Then we will calculate an mod x cos nx dx integration. Same here, we change minus pi to pi to 2 0 to pi here, and then we did integration. After integration, we put 0 to pi values here, and when we put 0 to pi values here, we get the result minus 1 power n minus 1, and outside of the bracket 2 upon pi n square. And you don't know about n. What is n? If it is even or odd? If it is even, when we put even value here and 2, the whole function will be 0. If it is odd, it will be minus 4 upon pi n square if we put n equal to pi here. Next, we will put a naught, an, bn values in the first equation. And when we put a naught, an, bn values, you know that this is the first equation. And an value is this. An value is this. We solved already. Bn is 0, you know that. So bn, this term will be not in the answer. So only a naught. A naught is pi by a naught by 2. That will be pi by 2. And what is an value? An, if n is even, then that will be 0. If n is odd, that will be minus 4 upon pi n square. So when you put an equal to 1, if that is odd, then you will consider this value. If you put n is equal to 2, you will consider 0. So when we put odd value, we get this. When we put even value like cos 2x, that will be automatically 0. So the last answer will include only odd terms. And odd terms, that will be the answer minus 4 upon pi n square.